We're going to be looking at the properties of logs to help us expand and condense logarithms. We'll need these properties in the next lesson when we start solving, because being able to use these properties will help us solve logs that we couldn't otherwise solve. So just keep in mind what we know about logs already. So if we have a log base b of x equals y, that can be rewritten in exponential form, where b is our base, y is our exponent, and then the argument x becomes our solution. So this entire log expression, log base b of x, is essentially the exponent y. So logs are exponents, and because of this, they have similar properties to exponents. Our product property says that when we are multiplying two things in our argument, so u times v, this can be rewritten as two separate logs being added. It's just like when we have our exponents with the same base, say a to the power of 2 times a to the power of 3 is a to the 2 plus 3. So we're adding our exponents when we multiply with like bases. Here, if we're multiplying, we can add our logs, since logs are the same thing as exponents. Okay, so same thing with quotient. Quotient is division, so if I'm dividing in my argument, I can rewrite this as two separate logs being subtracted. Just like when we subtract exponents, when we divide with exponents with the same base, we subtract the exponents, so a to the 3 minus 2. And then power property, so if we're raising the argument to a power, just like when we raised something with an exponent raised to another power, we multiply here. So that's exactly what we're doing here. The exponent becomes the coefficient being multiplied times your log. And then the zero product property. If we have a base of a raised to the power of 0, the argument will always end up being 1. Okay, so let's use these properties to help us do a few things. We're going to start by expanding. We need to keep in mind when we're expanding, our goal is to have single terms or a single term in each argument. And no exponents. So I will know that I'm done with expanding when I only have one term in each of my arguments and there's no exponents left. All right, in this very first example, if I look at my argument, which is the 4x, right now I have two terms in the argument. I have a 4 and I have an x. So I need to use one of my properties to split this up into separate logs. We're going to use the product property because we're multiplying 4 times x. And we're going to split this up into two separate logs. They will both be log base 2, since that's what we started with. So log base 2 of 4 plus log base 2 of x. Now I know I'm finished because I only have a single term in this argument of 4 and a single term in my second argument, an x. So this is the expanded form. Let's look at number 2. We're dividing, so we're going to use the quotient property. And right now I have a 3 and a 2 in my argument, so I have two different terms. So I need to split this up using that quotient property. So we'll have log of 3 minus log of 2. Now I know I'm finished because each argument only has one term and we have no exponents. In example 3, I only have one term in my argument. However, I do have an exponent of 2. So we need to get rid of that exponent, and the way we're going to do that is by using the power property. which tells me that the exponent can be written as a coefficient being multiplied times my log. So this is the same thing as 2 times log base 2 of x. And now I know I'm done. I only have a single term in my argument.